Welcome back to Math 160. So we're continuing in our Unit 1 notes. We actually left off on page 8. So if you look at page 8 of your notes, you had a practice number 4 where you were able to decide, is this particular statement referencing quantitative discrete, quantitative continuous, qualitative nominal, or qualitative ordinal. You took this home with you and you attempted these problems. So I would love to see how you did. So let's switch over to the notes and let's kind of dive in. And you could just shout out answers if you would like. All right. So for number 1, the temperature in Rochester, New York at 11 p.m. on any given day. What did you say was the type of statement below?
I said quantitative discrete, but I wasn't sure because you can count the oh wait, no, it wouldn't be that because you can do 11:30 as well.
Yes, in which case it would be quantitative.
Continuous.
Yeah,
yes.
Continuous. Beautiful. So we're looking at temperature as quantitative continuous. When you think about this, Surajini pointed out, like even in that dialogue, and I was very grateful for that dialogue, but the fact that like you can have that half mark, right? So like you can have 74.5 degrees outside. You can have those decimals. So temperature sits on a continuum essentially. And we know this because even when we're taking our own body temperatures, we can have those points, whatever, that point of a degree. Excellent. Number 2, the make of automobile driven by each faculty member. That's grammatically incorrect, but that's okay. So what do you all think? The make of automobile driven by each faculty member. What would you call it? Is this quantitative or qualitative? Emma, very nice. Qualitative nominal. Excellent. Thank you so much. That's totally true. So qualitative nominal. I might as well use the notation that I specified up top. Perfect. We are talking about the make, right? Qualitative because it's a name. Nominal, again, because it's a name. Perfect. Number 3, the length of time it takes you to drive to MCC. You can shout it out or type it in the chat.
Just wondering, is it like continuous because you keep going?
Yes, absolutely. Okay. It is continuous. So we're going to call this quantitative continuous. The length of time it takes you to drive to MCC. And that can vary, right? That can vary by a number of factors. So absolutely, it's on a continuum. Very nice. Number 4, the number of names you have collected for the petition. Who else? Who else? Someone else could do this. You guys got this. The number of names you have collected for the petition. I'm going to start calling on you. Aha, Kelly, Donna, very nice. You said qualitative discrete. Perfect. The number of names, you can't have any like half names. You know what I mean? Like you can't say, oh yeah, I collected 14.2 names. I collected 14.5 names. You know, you're not going to say that even if you are trying to be funny. So this one's quantitative discrete because you can only have a whole number of values. Very, very nice. Number 5, the number of colors used in a statistics textbook. What do you think?
Is it the same as quantitative discrete because it says number again?
Yes, perfect. And more specifically, we know that with the number of colors, Nick, excellent. We know that with the number of colors, we're not going to say I'm using 7.2 colors, right? We're automatically saying we're using whole number of colors here. Very nice. And last but not least, after your car is fixed, you receive a survey in the mail to fill out. The survey wants you to give your opinions on several items on a scale of 1 to 5.
I'm sorry, I don't want to keep talking, but I have quantitative continuous because you're counting.
We are actually putting something in a rank. So I see some answers in the chat. We've got Donna, Emma,
Oh,
Grace. Yes, we're actually looking at
very well.
qualitative ordinal.
Mm.
Think about ordinal as putting things in an order. And I think specifically because of that scale 1 to 5,
Mhm.
putting things in order or ranking. When you think of qualitative ordinal, I want you to think of putting things in order or ranking. Very nice. Excellent. Thank you, Sarojini. That was beautiful. All right, let's turn the page and continue. By the way, one of your homework assignments, so actually, I'm just going to show you really, really quickly while I have you all here. So you have your homework assignments here. We are going to set due dates. With this particular application problem, if you look at the first, I'll just do teacher preview. If you look at the very first one, take a look. So question number 1, you have the opportunity to write down your own examples of each of these types. Now, you're not allowed to use the examples from the guided notes, and I will know this, so don't do it. Just get creative, use your own examples. Notice for number 2, you have a question. It's talking about population, statistics, sampling technique, which we'll get to. Is this bias? We'll talk about bias. And then, you know, your own kind of perspective on how you would reach more people. The last question deals with sampling pitfalls, which we will most likely get to today. So we'll see how that goes. But notice that these are open-ended. So once you have completed this and submitted your answers, I have to manually go in and I have to read each of these answers to make sure that they make sense. So I will be grading these after the due date. Okay, so please be patient. Wait till all of the assignments are due so that way I can binge work and then plow through all of them together. Okay, that's I don't like doing, you know, one assignment at a time. That's just weird.
So I did mine. Could you check, like after the lecture, maybe when you get time, can you check mine to see if I am on a, you know, on the right path?
Oh, sure. You and I can actually talk about that. You're right. And let's come up with a plan to do that. We'll come up with a plan. No worries.
Okay.
Beautiful. All right, let's switch over to the notes. And let's move to page 9.
Would you mind putting that back for a second?
No,
I came in late. I was having issues with Zoom for some reason.
Oh, shoot. Can you see that okay? So we have quantitative continuous, qualitative nominal, quantitative continuous, quantitative discrete again, and then qualitative ordinal. Leah, no problem. Thank you. Perfect. When you're all set, just let me know.
Yeah, I am all set. Thank you.
Beautiful. You're welcome. And as a reminder, once we are done with our Unit 1 notes, I always scanned my copies and I put them into Lumen so that you have my handwritten notes. And that will be for forever. Okay, plus you do have this video that I'm going to be uploading and then putting the link in Lumen as well. So you always have access. If you have to go back and watch it again, no big deal, you'll have access. Okay. So collecting sample data, it is important to obtain good data because the inferences made will be based on the statistics obtained from this data. So you want to be really intentional with how you collect your data. These inferences are only as good as the data. So there are 2 methods commonly used to collect them, and that's experiments and observational studies. Now, these are different, and I hope that in our discussions, you'll see the difference between an experiment and an observational study. So first off, the experiment is when the investigator controls, I'm going to do a highlight here. When the investigator controls or modifies the environment and observes the effect on the variable under study. So it's an experiment because you're actually conducting an experiment. You are controlling or modifying the environment. Now you can do that through replication, blinding, or randomization. So replication is where the repetition of an experiment is done to more than one individual. Why do you think replication would be so important to an experiment? Think about like conducting studies. Think about there being questions that you might want to answer as a researcher. Why do you think replication would be important?
To establish a baseline.
To establish a baseline. I love it. Good. Tell me more. Replication is where the repetition of an experiment is done to more than one individual. Why would you do that? You establish a baseline. What else?
To make sure you get the same results.
Okay, interesting. That's actually a very interesting concept. You're conducting the experiment again and again and again to see if you're getting the same results. Doesn't that seem counterintuitive? Wouldn't you want different results every time? Talk to me about that.
I would want different results so that I can look over like what mistake I made or how to improve it. So
Okay.
like if it was something different and then I noticed I could change it, I would look over my old ones and be like, okay, now I could change it into a different like experiment or hypothesis.
I love that, Lucy, and you hit the nail on the head with that word hypothesis. So essentially you'd want to kind of see that to hone in on maybe a particular hypothesis that you're looking for. That's a very interesting perspective, but it is possible that you could get the same result every single time. Is that a good thing? Is that a bad thing? Talk to me about that. What are your thoughts?
It could be a good thing.
It could be a good thing.
You get to see that you're doing whatever you do, you're still getting the same exact result.
Right. So maybe the tool that you're using is actually measuring what it's supposed to measure, right? Interesting. Okay. And that concept has to do with validity and reliability, but that's another topic. Excellent. Let's go back. I do want to add to that this requires the sample size to be large enough to see the effects of the treatment. So if we want to replicate, we need to make sure that the sample size is large enough so that we can see what's actually happening. As an example of this, that could be testing the effects of the same drug on a large sample of patients. We want to collect enough data so that we can figure out what's happening. We can see if the medicine or that drug is actually effective. We can see what kinds of side effects this drug will have. You want to test on a lot of patients so that you can collect good data. That's where replication comes into play. You could conduct an experiment that includes something called blinding. And blinding is used when the subject doesn't know whether they're receiving a treatment, right? Is used when the subject doesn't know whether they are receiving a treatment. What's it called if they're not? What's it called if they think that they are, but they're actually not?
Placebo effect?
Yes, placebo effect. Yes, good. So they're not sure. They think they are, but it is possible that they're not, because you're using blinding for an experiment. Blinding is a good way to get around the placebo effect. Which occurs when an untreated subject reports an improvement. And it doesn't necessarily have to be an improvement. It could just be an effect, period. They could report feeling deficient in something, and then you're like, well, I didn't actually give you the treatment. So you have some sort of placebo effect. There's another aspect to blinding, and it's actually called double blind. And double blind is when neither the researcher nor the subject knows if they received treatment. So the researcher doesn't know if certain patients received treatment, nor do the patients. So that's called double blind. Let's write that in here. So neither the researcher nor the subject knows if the subject received treatment. That does not mean it's a free-for-all. There is still a lot of organization. There's actually more so in a double blind. Typically, there's a third party who actually knows this data, but the researcher themselves do not know whether or not the subject received the treatment. They do it to take out any bias that the researcher may have, especially when collecting the data or making observations. They want to take out some of that researcher bias by including a double blind component. There's always going to be a third party involved with a double blind. And lastly, we have something called randomization. So this is where the individuals are assigned to different groups through a process of random selection. So this is where the individuals, your subjects, your patients, are assigned to different groups through a process of random selection. Okay, randomization, this is where the individuals are assigned to different groups through a process of random selection. There are actually several ways to select randomly. We actually will have the opportunity to talk about those sampling techniques. At the very bottom of the page, we have a note here. Mike, would you do us all the honors of reading that note out loud for everybody?
Sometimes in an experiment, confounding occurs when we can see some effect, but we can't identify the specific factor that caused it. For example, an experiment was performed to see if exercising would help a person lose weight. The results showed this was not the case. Why?
Thank you so much, Mike. What are your thoughts? Let's think about this very current relevant issue. Let's say that an experiment was conducted, but something happened. The person isn't losing weight after exercising. What do you think is happening? What could be the confounding factors?
Their diet.
Oh, tell me more.
If they're eating McDonald's and Burger King all day, every day, and still exercising, they're still going to get fat.
Right. They're still going to unfortunately gain weight despite the fact that they're exercising. So oftentimes when we look at research that is presented, it's really important to look for confounding factors, other things that might be in play that we don't quite see firsthand, to make sure that we're understanding the bigger picture. And as researchers, as statisticians, that's exactly what we need to do all the time. We need to make sure, is there something else that could be contributing to this? Or is it actually, you know, maybe some sort of deficiency? Beyond diet, it could be actual deficiencies. It could be hormones, right? There could be some issues with thyroid issues, things like that. So there could be biological influences which are preventing that person from losing weight as well. So it could be a bunch of things in addition to possibly just nutrition. Very nice. Excellent. Let's turn the page. Okay. Next, we have our observational study, okay? So I want you to think of observational study as very different from an experiment. With an experiment, you are modifying the environment. With an observational study, data are obtained by sampling some of the population of interest. The investigator does not modify the environment. I'm going to highlight this. The researcher simply observes what is happening and records observations, okay? That's all that's happening in an observational study or survey. So, for example, consider someone on a busy street in a New York neighborhood asking random people that pass by how many pets they have. Then taking this data and using it to determine if more pet stores should be in the area. Notice that all this researcher is doing is hanging around, asking people, hey, how many pets do you have? And then collecting this data for maybe a week, maybe a month, maybe 3 months. And then using that to determine if there should be more pet stores in the area. That would be an example of an observational study. Notice that the researcher isn't manipulating the environment at all. Beautiful. So we have a process of data collection. So number one, define the objectives of the survey. What are you trying to find out, right? Define the variable and population of interest. So who are you actually going to talk to? Who are you actually going to survey? And what's going to be that particular question that you're answering? Number three, define the data collection and data measuring schemes. This includes sampling procedures, sample size, and the data measuring device. So it's essentially describing how you're going to conduct your study, right? You want to be able to define all of this before you actually go out and do it. That's actually a really important process that I think a lot of people don't realize must be done before you actually conduct your survey or your study. As an example, a survey was conducted to determine what brand of laundry detergent women purchase most often in the Rochester area. So what do you think is the objective of this particular survey? And you could just shout out your thoughts.
The brand
Brand
that
of laundry detergent.
Okay, to figure out the brand of laundry detergent that's purchased most often. Okay, so let's write that down. To figure out, oops, let's write what brand. To figure out what brand of laundry detergent is purchased most often. What's the variable? It might seem a little repetitive, but think about what are we measuring?
Brands of laundry detergent.
Yes, perfect. Beautiful. That's the thing that's going to vary, right? Wow, I'm drawing a blank. I cannot think of any laundry detergent. Tide.
Gain.
Game.
Dove, the Dove one, they have a Dove one, or Dawn.
Ooh, that's pretty sweet.
Downy.
Downy.
Wegmans.
What? Yes. Oh my God. Yes. The Wegmans generic brand. I didn't even think about that. Yes, absolutely. Thank you all. I totally blanked out on like literally everything. That was pretty terrible. And then how would you gather your sample? How would you do it? What would you do?
Probably like in a grocery store. Just ask people, I guess, if they're in that aisle.
That would
I
work.
would do it in a laundromat.
Laundromat. Oh, clever.
Like
Very
an
nice.
observational study at a laundromat.
Good. Observational study in a laundromat. I love this. Any other ideas of what you would do? So you could go to the store, you could go to the laundromat.
You could walk up to each person's house, or you can conduct a survey in the area.
Yes, so you can go in a neighborhood and just kind of move from house to house, right? Because you want to see what they're actually bringing into their home, obviously without entering their homes. Yeah, that's absolutely correct. I love it. For this, how could we gather our sample? Write down what you would do. This is a very open-ended response. This is completely up to you. What would you do? Would you canvass the neighborhood? Would you go to your local grocery store and ask people who are in that aisle? Would you go to a laundromat and ask individuals there as well? Excellent. So this is really open-ended. I'm just going to write there in many different ways.
I have a quick question. Can
Yes,
you ask the source for these data as well?
Yes.
I'm thinking the same thing.
Yes, and why not? That's absolutely correct. Why not? If you want to collect massive data, you would go to the source. You would say, Wegmans, what are you selling and how many of each brand? Now, the only issue is the example says a survey was conducted to determine what brand of laundry detergent women purchase most often. Now we're getting into demographics.
Oh,
So,
women.
yeah, so we want to somehow narrow down those demographics, but it is possible that Wegmans has data on that as well, if the information is linked to particular accounts. But then we have to get into, okay, how do we identify gender and things like that? So it would actually be kind of a complicated problem for sure. I would imagine that, especially now in 2021, I mean, while we do still collect demographics, I think we're still a little bit more, I think we're now more open-minded about that and gender fluidity and things like that. Beautiful. All right, let's go ahead and turn the page. That was awesome. I always like hearing all of your thoughts on like what you would do personally. That's very cool. Okay, we're moving into biased sampling techniques. Now, that doesn't always necessarily mean bad. When you think bias sampling, I don't want you to think poo-poo, like never do this, because sometimes you really only have those options. Just keep in mind that they could be very biased, you know, but don't panic about that. Okay, let's take a look. Biased sampling techniques. So this is a sampling method that produces values that systematically differ from the sampled population. It could be, right? So we have something called convenience sampling. When you think of convenience sampling, I want you to think of those surveyors in the mall. Like when you walk into the mall and then they have their clipboard and they come up to you and they say, hey, can I ask you a question real quick? So they're waiting around in the mall trying to collect data from people who are who just happen to walk by. So that's convenience sampling. So convenience sample, sometimes called a grab sample. I think that scenario helps to solidify why it might be called a grab sample. Occurs when items are chosen arbitrarily from elements of a population that are easily accessible. So there's no rhyme or reason, for instance, for the people with clipboards in the mall. They're just looking for people to answer their survey. Typically, it doesn't look like they're looking for specific people. They're just saying, oh, you're passing by me. Hey, can I collect your data? So let me write an example here. And you can actually write any example you want, but I have one that I wrote down. I said, I am interested in the type of items people buy online via Facebook advertisements. So I survey only the people in my Facebook friends list. Do you see how that can be really convenient? I'm going to write that down just so we can think about how convenient that is. And then I want to talk about why you think that might be so biased. So I am interested in the type of items people buy online via Facebook. I hope you don't mind me abbreviating via Facebook advertisements. I, for the record, have never done that. I have, however, purchased things through Instagram advertisements. I will admit that, but I have not succumbed to Facebook advertisements, not yet. What about you?
I'm about the TikTok advertisements.
TikTok. Oh. You know, I've never used TikTok. I want to, I just never used it. I don't know why I'm like slow on the uptake. I just have not even looked at it. I haven't even looked at it.
It's an addiction for me.
Maybe that's why. It's like my unconscious brain is like, don't do it. Because if you do, you'll never return. There are some advantages and disadvantages to this whole convenience sampling, but I think that leads us to that conversation. Why do you think that's biased? What's going on here in this scenario?
You're only using your friends list.
Which means what, Kelly? Why is that an issue? My friends are awesome.
Because if you're not buying anything on Facebook advertisements, and they probably aren't either.
This is true. That's a very good point. What else? Why else is this an issue?
You said something earlier about like a trust process, and if it's your friends, then like you have like more contact with them. It's not really random.
Right, it's not random at all, Leah. You're totally right. I'm just trying to do this in the most convenient way possible. And I figure why not just ask the people that I have direct access to? But like Kelly said, we probably think alike, right? I mean, a lot of our friends, when we have conversations with them, more often than not, we might actually think quite alike, which is why we probably befriended them, right? I mean, you know, if you have very differing views, especially political, right? I'm probably not going to associate myself with you for obvious reasons. So you generally have people surrounding you that think like you. So yeah, that could be a huge pitfall. One of the advantages that some of the advantages that you can have with convenience sampling is, and think bigger picture, is the fact that it's cheap, affordable, and easy to collect, right? It's quick. You can just wait around and collect data. It's no big deal. But the disadvantage is it's easy to provide false data and it's hard to replicate results. I think those are the two things you have to consider when conducting sampling using convenience techniques. So let me write that down for you. Advantages, disadvantages. I want you to, let me change this view so I can see it. I want you to write that it's cheap, affordable, easy to collect. But on the flip side, it's easy to provide false data. I would be foolish to think that only my friends list, surveying my friends list, is enough to give a bigger picture of the population itself. That would be pretty absurd.
Couldn't that be a lot of data too, since like you on Facebook, they show you advertisement for things that you like. So everyone could have different advertisements. And wouldn't that just collecting a lot of data?
Yes, and in which case, if we did run this kind of study, it would be a binomial distribution in the sense of, did you buy it or did you not? And then you would say, I'm not even going to focus on the type of advertisements or what you bought, because that could be pretty personal too. You would probably just want to say, have you ever purchased an item from Facebook advertising, yes or no? And it would be as simple as that. But that's a great question. It could be too much data. And you're right, you want to sift through that and get to the bottom of it, which is, have you or haven't you? And so you would just ask that simple question. Awesome. Another type of biased sampling technique would be something called volunteer sampling. So a volunteer sample consists of results collected from those elements of the population that chose to contribute the needed information on their own initiative. So as an example, it's surveys you get in your email, right? Surveys you get in your email. You can choose whether or not to answer those survey questions. So you would think this might be a little bit better than convenience, because people are just taking it upon themselves to opt in to that survey. But there are still advantages and disadvantages to this. So the first thing is, I'm going to write this note and we'll talk about this. So people having an interest in that product, oops, are less likely to give biased info. So if that person genuinely has an interest in that product that's being surveyed, they're less likely to give biased info. They're actually more likely to be upfront about what their experience is and what it's, you know, maybe details about that product that would be helpful to other consumers. Which is actually pretty helpful. The issue is it could take a long time to get responses. You know, if you're trying to collect as much data as you can, but you're waiting for people to volunteer themselves, it could take a long time. It could take a really long time. You'd have to market it effectively so that people will want to take the survey and provide their feedback. You can do that by incentivizing them, right? Maybe if you fill out the survey, you will get a $5 Starbucks card or a $10 Starbucks card. That would be an incentive for a lot of people, right? So you could potentially speed that process up, but it also could take a very long time to collect those responses. And then lastly, it is possible that your data that you collected from these volunteers, that it doesn't adequately represent the population. We don't know that for sure. And that's because people are choosing to take that survey. So it's definitely biased. It's more than likely that it doesn't adequately represent the population as a whole. We also have something called judgment sampling. So I'm actually going to give this to, let's go, Emma. Emma, would you read this little blurb here about judgment sampling?
Sure. Samples that are selected on the basis of being judged typical. The person selecting the sample chooses items that they think are representative of the population. The validity of the results from a judgment sample reflects the soundness of the collector's judgment. This is not an acceptable statistical procedure.
Yeah, it's actually pretty, it's really, really tough to use judgment sampling and call that valid. So first off, notice what Emma said. The person selecting the sample chooses items that they think are representative of the population. There's a lot of things that could influence this. There could be this idea of access, right? Like, and then the researcher themselves are making their own judgment call. So I'm going to write here an example, and I'm going to write university president selection. And let me explain. So imagine that you have a researcher who is interested in collecting data from university presidents. And what this researcher does is that they select university presidents at, you know, common colleges or universities across the nation, but universities that maybe resonate with that researcher themselves. Then you get into this idea of, are we actually collecting diverse enough data, right? Are we looking at the real demographics behind university presidents? Did we figure out the demographics first and then try to collect data from university presidents that contribute to that set of demographics? Does that sample reflect the population as a whole? So if you have a researcher who's simply using judgment sampling and deciding, I'm just going to use this president and that president and this one, and you're just like, well, what was the rhyme or reason? And then that individual says something like, well, I have access to those individuals, or maybe those individuals, I feel like I resonate with them because they look like me, or they're from similar backgrounds that I am, etc. You're not really getting the bigger picture at all. You are literally leaving portions of the population out of that story, out of that dialogue. So judgment sampling could have some serious issues. So when you think of that, think judgment call. And I want you to consider the fact that researchers themselves naturally can be very biased. So you want to stay away from judgment sampling if you totally can. You definitely want to stay away from that. When you are conducting a study, you want to make sure that your sample is a small replica of the population. And if you can't do that in that particular regard, then you need to go back to the drawing board. Good. Any questions for me so far? We've covered a lot of information. You're all doing wonderful. Okay, let's turn the page. We have something called a sampling frame. When you think of sampling frame, I want you to think of a list or a set of elements belonging to the population from which the sample will be drawn. So for instance, you want to think of like a directory, right? So like if you wanted to sample all of the faculty at MCC, you'd probably go to the employee directory. You'd look at the employee directory, which is the sampling frame. So I'm going to write that down, employee directory. Right? Because that has a list of all of the employees that belong to that population. And in this case, it would be the employee directory at MCC. If you wanted to survey the faculty at MCC or even the staff, you have that directory. That's your sampling frame. Let's say you wanted to collect information on the number of accidents that people have. So your sampling frame in this case would be licensed drivers. You actually have a list of licensed drivers, and you'll use that to kind of sift through and collect your, you'll collect your sample. You use some sort of random technique, but using that list to help you pull individuals from. Good. Next, we have a set of unbiased sampling techniques. And I'm going to go through this in a way that I hope makes total sense. So let's take a look at the first one. Let's start with simple random sampling. Anthony, would you read that out loud for everyone to hear? Simple random sampling.
Every random element of the population has an equal probability of being chosen. All samples of a size have an equal chance as well. Proper procedure for selecting a random sample requires the use of a random number generator or table of random numbers.
Score. Thank you so much. You really want it to be random. You're not just going to like assign people numbers randomly as an individual. No, you want to use some sort of random number generator or a table. I mean, this is hugely old school. I have never seen a person use a table of random numbers. I can't believe that's even still here. I think that's very archaic, a thing of the past. Now you're looking at random number generators, like actual software that will give you random numbers. Good, but it's super simple. So as an example, we have bingo. Bingo is a great example. The reason bingo is a great example of simple random sampling is because imagine what happens. You have a container with all the little bingo balls. They're all the same weight, same size, same shape, same everything. It gets spun around and then it pops out randomly. It couldn't get more simple than that. Another example is the lottery, right? You pick random numbers, same thing. The random numbers are chosen that particular evening or morning or whatever it is, but there's no rhyme or reason for it. There's no way that one particular number could come out more often than another because of the fact that probabilistically their chances are equal. Okay, so super simple. To get a little bit more complex, we have something called a systematic sample. So Sam, would you read about systematic sampling? Oh, you're on mute. Sam, you're on mute right now. Oh.
My bad. A sample in which every item of the sampling frame is selected, starting from the first element, which is randomly selected from the first K elements.
Yes, okay. So that's kind of a strange way of saying that you first, and I'm gonna write out the process for systematic sampling. So step one, arrange items in an order 1 to K. And when I say K, I mean it could be 1 to 100, it could be 1 to 200, it could be 1 to 30. It doesn't really matter, but your items are arranged from 1 to whatever it is. And that doesn't have to be any specific rhyme or reason. You're just assigning a number to each individual and or each item, and you're putting them in order. Step two would be to take every kth item. So that's kind of, again, a really weird way to say this. Actually, let's change it from K. Let's use N instead. Let's use N in this case. I apologize. N in this case will be the total number of elements in your sample. I'm going to write that down. N is total number of items in sample, because N typically represents that, the total number of items or the total number of people or something like that. So you arrange your items first, and then you take every kth item. So what I mean by that is, like, for instance, every fifth item, every 10th person, etc. That's systematic sampling. If you wanted to ask students at MCC, I don't know, you just wanted to collect data from students at MCC. If you chose to use systematic sampling, you would arrange the group of students, 1 through whatever number it is. And then you could potentially say, I want to take every 10th person in that particular ordered sample and use them for my study. That would be systematic sampling. Any questions on systematic sampling?
I have a quick one.
Yes.
I'm sorry.
Go for it.
So if you have 20 people, you count up to 10 and you pick that 10 person, number 10.
If you have 20 people, you would arrange them from 1 to 20. So it could actually be like this class. So I could give a number 1 through, how many of us? 29. 1 through 29 in this class. And then I could say, you each have your number, so you know what they are. And then I would say every third person, you'll be part of my group.
Okay.
Does that make sense?
Yeah.
Beautiful. Excellent. And that's systematic. Think of there's a system in place, and that system is every third person, every fifth person, every whatever it is to be part of my study. Beautiful. Next, we have something called stratified random sampling. Stratified, think strata, like groups, like layers. I know you've seen this in biology. So Megan, would you read the information here on stratified random sampling?
Subdivide the population or sampling frame into strata groups with the same characteristics and then randomly sample within those strata using a fixed number of the same proportion from each strat.
Yes, I don't know why that is here. It should be here. Okay. Yes, you're absolutely correct. When you think of stratified, I want you to think strategy. And I want you to think there is a rhyme or a reason. You have a strategy for how you'll want to put individuals or items into groups, right? So let me give you an example. What if I said to all of you, any students who are the only child, you will go in group 1. Any students who have 1 sibling will go in group 2. Any students who have 2 siblings will go in group 3. And then any students who have 3 or more siblings will go in group 4. Do you see how what I'm doing right now is I'm saying, I'm going to use a strategy of the number of siblings that you have. And what you'll do is you will put yourselves in these groups based on the number of siblings that you actually have. What I will do as the researcher is then I will select people randomly from each of these groups to be part of my study. Does that make sense? So I have a strategy in place first for how to divvy you up, but then I am going to select randomly from these groups so that I collect a lot of information. I want to make sure that I have thorough, good data. So you can write that down however you'd like. Another example would be if you're looking at a high school and you want to break down the student body by grade level, freshman, sophomore, junior, senior, and then you randomly selected people from each of those classes. That's stratified random sampling, okay? And notice that you're using a fixed number or the same proportion from each group. So if I choose 20 people or 20 freshmen, I'm going to choose 20 sophomores, 20 juniors, 20 seniors. So let's write down our example. I'm going to use the first one with the siblings. So I'm going to write breaking the class into subdivisions. Based on the number of siblings. Then randomly choosing from each group. In which case, I'd probably use a random number generator to choose from each group. I'd assign everybody a number and then I'd use a random number generator to figure out who's going to be part of my study. With stratified sampling and cluster sampling, these two get mixed up all the time. These two literally get switched back and forth like literally all the time. Hopefully this dialogue that we have now and really focusing on the fact that stratified sampling, you have to have a strategy in place first, right? You break up the group based on some sort of characteristic, and then you randomly choose. So Grace, would you read the information about cluster sampling for everyone, just so we can kind of hear what's going on, the difference between stratified and cluster. Go ahead, Grace. What do you see here?
A sample obtained by stratifying the sampling frame and then selecting some of the strata and using all the members of the selected strata. In other words, you randomly divide up your population into subgroups and then you randomly select samples from each group.
That's huge. I'm going to highlight that. In other words, you randomly divide up your population into subgroups and then you randomly select samples from each group. If we met in class, at this point, we would play 4 corners. You're probably thinking, are you for real right now? Yes, we would play 4 corners. And what I would do as the researcher is I would stand in front of the room and I'd close my eyes, and you would all select your own corner, 1 through 4. What I would then do with my eyes closed as everyone's in their respective corners, I would then randomly select which groups to choose. So maybe I would choose groups 2 and 4, you know, or 1 and 4 or something like that. When I opened my eyes, those individuals who were in those particular groups would then become part of my study. So when you think of cluster, I want you to think of like actual clusters, right? There's just kind of no rhyme or reason. Think of like a bag of delicious, you know, chocolate and nut clusters, and yeah, so freaking delicious. Maybe with some like caramel in there or something. I don't know. Okay, sorry. But they're just clusters. They're randomly strewn about in that bag. I want you to think of that in a statistical lens, that you have this kind of random experience. There's no rhyme or reason why people are moved into certain groups, but they're moved into certain groups and then you randomly select from those groups. You could randomly select from each, or you could randomly select particular groups. Okay, so that's the difference between stratified and cluster. Stratified, strategy, cluster, just kind of groups.
So the groups can like have different amounts of people in it. But you
Yeah,
can...
absolutely. They definitely can. And typically that's what you'll end up finding out. Like for instance, we could say, like if you're looking at zip codes and you're looking at particular neighborhoods, they could have very differing sizes, but you can still randomly select from those groups as well. Okay. So there's no specific strategy that you're applying first. That's what you should think about when you think of stratified. There's a specific strategy you're applying first. Okay. For this one, what I could write here is just think 2 levels of randomization. And you can write that down. Actually, I'll write it here. Think 2 levels of randomization. Score. We only have 6 minutes left. And of course, I'm sure you guessed it, we have a practice activity. So what I'd like us to do is spend these last 6 minutes going through these statements and answering what we think is that particular sampling technique. Notice you have a word bank up top. You have volunteer, judgment, simple random, stratified, cluster, systematic, and convenient. So I would like us all to spend the last minutes of class answering these as best we can. And I am so sorry. I am actually going to interrupt what you're doing because we need to come up with some due dates. So for Monday's class, we will finish looking at this particular page. We'll reveal the answers on Monday, and we will also finish these notes, which means you should have Unit 2 notes printed and ready to go for Monday. Okay, keep that in mind. In terms of due dates, I assigned this first assignment due on the 15th. I want to do the same thing with understanding the difference between populations and samples. Are we all okay with that, with these 2 assignments being due in 1 week? Okay.
Yes.
Beautiful. So let's have them due on the 15th. Perfect. If your heart desires, go into the Unit 1 application problems and start answering these. Like you can do all of question 1. You can do all of question 2, but you can't do question 3 yet. We will be looking at question 3, these topics at the beginning of Monday's class. We're already on page 14 of 16. So we will finish very quickly on Monday. Okay. Anyone have any questions on that?
So we're just doing practice 5 by Monday?
Yes. Yes. Practice 5.
And
then I would, if I were you, I would start tackling those 2 homework assignments so that you don't have to worry about them later in the week.
Sure thing. And I don't know if like the other students are having issues with Zoom, but like when I went through Lumen, it wasn't like, it wouldn't launch my meeting.
Wow. Is anyone else having that issue too? Cheng,
Works for me.
what you may want to do is just write down the Zoom.
Like I emailed you before yeah. So like I emailed you before class and whatnot. I was like, I can't get in for some reason.
Yeah, what the hell? That's so weird. Yeah, just if you want, just write down the
All right.
ID and you don't even need to click it if you want. You can just open Zoom and then type that in.
Okay, sounds good. That's pretty much what I did.
Beautiful. All right. Very,
All
very
right, thank
nice.
you.
You're very welcome.
I
All right,
have a
everyone.
question.
Oh yeah, Emma.
Sorry. If you do question number 1 and 2, will it save it if you exit because you can't do 3 just yet?
Yes, absolutely.
Okay.
Yep,
Okay,
absolutely. Everything you type in there is automatically saved. Perfect. Beautiful. All right, everyone. Have a wonderful weekend. Make sure it's nice and productive. See you Monday. Make sure you print out your Unit 2 notes, but I will send a recap email. Bye.
Bye.
Thank you.
You're welcome. See ya.
Bye.